Hey guys, welcome to our channel Coders Arcade. This is Ashank David, and in this video, I will be talking about how you can do insertion sort. Say suppose we have an array here and we need to apply insertion sort. How to apply insertion sort? Now, before I start with this video, I would like to request you to people all like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also so that you won't miss any future updates. And for those people who are new to this channel, let me tell you, this video is part of a playlist where I'm creating all the algorithms in one place. So if you haven't watched our previous videos yet in the playlist, I would highly recommend you to watch those other videos also in the playlist. Now, without any further ado, let's get right into the concept. We'll understand the logic of the algorithm and then we will see the code. So let's say you have an array here. This array you have given, and the indexes starts from 0, 1, 2, 3, 4, 5, and let's say there are six indexes, totally 7 elements because indexes start from 0. Now I said I want to apply insertion sort into this. So what we will do is we will always start from the first index. Always. Never. We don't start from 0. We always start from the first index. Every time in insertion sort. Okay. So there will be a variable called as temp. Okay. Where we will be storing the variables temporarily for some time. Okay. So what we will do is we will start the iteration, and in the first iteration I will say we have 7 in the first iteration. Okay. Now what happens is this: in the first iteration we will compare it with the left element. Okay. We'll compare it with the left element. If the left element is smaller, then we don't have to worry about anything. If the left element is greater, then we will swap those two elements. Okay. So right now you see that 7 is greater than 4. On the left hand side, 4 is at the correct place. So we don't have to worry about anything in this case. So we will do nothing. We'll move on to the second iteration now. When the second iteration comes, now we will start from 2 right here. And what we will do is we will compare this 2 with its left, and then we will compare that element with its left, like this. Understand the point? So in the second iteration we started from the index 2. As we can see here, the 2 is smaller than the left index 1, which is 7. So in this case, what we will do is we will temporarily store this 7 right in the temp, and we will swap. I will make this as 2, and this will become, basically this is going to be 2, and this will become 7. Okay. This will become 7. And now I'm going to change that 2 with this 4. As you can see that now we will compare this 2 with this 4. What happens is this, that 2 is smaller than this 4. So again you swap. And when you do this, what happens is that this 4 will get stored right here, and this 2 will go here, and the 4 will come here. So this 2 will go right here, and this 4 will go right here. And you can see that our first element is reached. Under the smallest element has been reached to the left hand side corner. Now you do the same thing with 3. Now start with the next iteration. In the third iteration, you start from 3 and you go check it with the previous elements. So you can see that now we have 5, which is smaller than 7. So we will swap in this case with them. So what happens is store 5 here, not 5, store 7 here. We'll store 7 here, and we'll move this 5 right here. 5 came here and 7 went right here, like this. Okay, I'll just change the color. 7 came here and 5 came here. Now check this 5 with this left. Now this is the correct place, no worries. Now check this 5 with this 2. Now this is also correct, no worries. Now in this case, we'll move on to the next iteration. Nothing is changed here. Now we will change this to this iteration, the next iteration, and we'll move on one index further. So here what we will do is, now we will start with 4 and we will check that this 1 is smaller than 7. So what we'll do is we'll swap. And when we will swap, what will happen is that 7 can be stored right here, and then 1 can go right here. So I'll delete this. 7 will go right here, 1 will go right here. Now you see that this 1 is even smaller than the 5. So 5 will be stored right here, and then they will be swapped. So 1 came here and 5 came right here. Then again we see that 1 is even smaller than this 4. So what happens is swap by storing 4 into this, and this will become 1 and this will become 4. I hope so that you are getting my point. Now 1 will go here and it will be checked that if 1 is smaller than 2, yes, 1 is smaller than 2. So this will be done and it will be swapped. Here 2 will be stored and 1 will go right here. So now you can see 1 has reached finally to its correct position. 2 is also reached at the correct position, and this will carry on with the next iteration. As you can see right here, we have 3. So what happens is that 3 will be compared and 7 is of course greater. So 7 will be stored right here and they will be swapped. In this case, 7 will go here and 3 will come right here. 7 will go here. Okay. Now 3 will be compared with 5. So 5 will be stored right in the temp, and then 5 will come here and 3 will come here like this. And now you see that this 3 is not smaller than the 3 is smaller than the 4. Yes. So in this case 4 will be stored right here, and then 3 will be coming here and there will be coming 4 like this. Now this 3 is not smaller than this 2 right here. Okay. So what we will do is we will skip this, and then this is also correctly positioned. So nothing is there left. Now last iteration we will go here, and you can see that we'll again start from this iteration. We'll check if 6 is smaller than 7. Yes, it is smaller. So 7 will be stored and 6 and 7 will be swapped. Now you can see that 6 is not smaller than 5, nor it is a smaller than 4, nor 3, nor 2, nor 1. So now it has been sorted and we'll get the sorting done. This is what you call as insertion sort. I hope so that you have understood the logic really well, guys. If we talk about the time complexity, then it also comes up to order of n square. As you can see here, that we are going to continuously iterate and will continuously compare it while we are iterating, and for that we need a nested for loop, and hence the time complexity will come up to around O of n square, guys. Well, that's it for this logic, guys. Now we'll move on to the code and let's understand what happens and how this works. This is the code, guys, as you can see, and here what we have done is that here this is the logic for insertion sort. Okay. This is the main function. This is the logic for insertion sort in this case. So what we have done is we have passed the array in this function, and this is the size. And here what we are doing is we are iterating it from the first index. Iterating will start from the first index, and the key will become that first index itself. What we will do is we will check j. J is I minus 1. That means it's previous left, 1 left. And until and unless j becomes 0 and ARR of j is greater than the key, in that case you will swap it, and then you will do j minus minus. That means it will go even next left, and it will check with that previous one with the current one, and it will keep on happening until j doesn't become either equals to or greater than 0 and the ARR of j, that means that current element is correctly positioned into that place in the array, and then later on this will become the key. I hope so that this is very much clear to all of you. This is the logic for insertion sort. Now if you have any doubts, you can ask me in the comment section below, and I'll try to clear your doubts as much as possible, guys. Well, that's it for this video, guys. If you have any other doubts, please let me know. I'll see you in the next video, guys. Thank you so much for watching. Happy learning.